Yeah, but they get the surface area of a sphere, not a hemisphere. But is it just half? Is it just half of the surface area of the sphere?
Right. So what will be surface area of sphere?
4 pi r squared.
That's it. And so what would you do for this one?
I do. So 4 pi 5 squared, and then divide the answer by 2.
I'll just write times a half. So imagine, how do you find the diameter? Excuse me. How do you find the circumference of this circle? And its diameter is 12.
Is it pi times that diameter?
Yeah. And now, what would be the perimeter of this?
Um. Uh. Would it be 12 plus half of 12 pi?
Yes. And so this one up here, when our one is cut in half, so when it's cut in half, it creates an extra side. When this one's cut in half, it creates an extra surface.
Yeah.
Can you see what that would be?
So does it? So when it says total surface area, does it mean I need to find the surface area of like the flat side and the curved side as well?
Yeah, total surface area.
Um. Um. Is it just? Is it just again like 4 times pi times 5 squared times a half?
No. What shape do you have on the base that's sitting on?
Circle.
Yeah,
So is it just the area of a circle?
yeah,
So pi times 5 squared.
that's it. That's it. So just keep that in mind for circumferences. For half a circle, you have to add on the diameter, which you're already good for. And then this one is the same idea. So you're finding the surface area. So it's a hemisphere, so you're halving it for a sphere, but then by cutting it in half, they create that extra surface at the bottom. Any questions there?
No.
Okay. Okay. How about this one?
Um, um, is it just like two x equals to r or something? Or?
So the radius is 2x, yeah. Um, any ideas about it?
I don't think so.
If it's melted down, then
Yeah.
it's referring to its volume. So you'd have to find its volume.
That is one volume of the cylinder,
Yeah,
and it says here it's pi r squared times h.
yeah.
So, pi times 2x squared times 9x.
And simplify it.
Okay, so 2x squared is 4x to the power of 4.
Uh,
Oh, yeah, sorry. 4x squared
yeah,
times 9x times pi. Um, can that be simplified anymore? Or
Yep. 4 times 9.
4 times 9, sorry.
Mm-hmm.
36.
So 36 pi x squared times x.
X cubed.
That's it. So that's the volume of the cylinder. That is melted down into a sphere. What is the volume of a sphere?
4/3 pi r cubed.
And so that must be equal to 4/3 pi r cubed. You have to find what r is in terms of x.
Okay, so do I just rearrange to get to r?
Yeah.
Okay, so can I do 36? Can I do say 36 pi x cubed divided by 4/3 and pi?
Yeah, and so I can see right away, divide both sides by pi. And what would you get for 36 divided by 4/3? Do you have a calculator?
No.
You get 9 and then 27. So you get 27 x cubed is equal to r cubed.
Yeah. Do I cube root 27x cubed?
Yeah. So r equals?
Is it 3x?
Yep, that's it. R equals 3x. So the big picture is you have to find the volume of this cylinder. And when they talk about like it's made of this much stuff and it's melted down and turned into something else, it's referring to its volume.
Okay.
What it's made of. Yeah, so then it becomes, so we found its volume and then it's turned into a sphere. So that obviously has the same volume. It's just in a sphere form. And so 4/3 pi r cubed gives you that volume and then you just solve it for r. Any questions about that?
No.
Right. Okay, conversions. Let's make sure. Okay, how about this? Do you do miles in IGCSE?
Like we didn't do them in our papers, so probably not.
I think that they use things as an older one, but they don't do miles to kilometers anymore. I don't think we need that one. Let's see this one. Yes, this is it. Okay.
Okay, so do I need to convert um liters to gallons,
Yeah.
and then that'll be 1,700 divided by 4.5.
Okay. And then
Um, it says the answer is 377.7.
Okay.
And I probably should. I think I probably should have done gallons to liters.
It'll all be the same, I think.
Okay. Um. So. Um. Also, if it's 377, do I need to do 1700 divided by 370? Oh no. I'm not sure.
So they have 18,500 gallons in the fuel tank.
Yeah.
They pump 377.7 per minute.
Yeah.
How many?
Do I need to do 18,500 divided by 377.7?
Yeah. That's it. And that gets you your answer. And yeah, usually try to convert from the bigger unit to smaller unit, so you don't get decimals. You could have also done this original 18,500, change that into liters by multiplying it by 4.5 and then dividing it by 1,700. Yeah, any questions there? Okay. Let's see, we don't need that one. So this one, yes, if they give us the conversion.
So do I need to convert? Do I need to do? So do I need to find the ratio of miles to kilometers and do like 1 mile is equals to 8/5 or something?
Yeah, you could do that if you wanted.
And then do I do 120 divided by 1.6?
Yeah.
And then do I add that to 80?
Yeah.
So she doesn't have that fuel.
Yeah. That's it. Let's see. So exhaust with meters. Okay. Like this.
Okay, so do I need to convert grams to kilograms?
You could, yeah.
And is that 150 divided by 1,000?
Mm-hmm.
And then is that like 0.15?
Mm.
Yeah. And then do I times 0.15 by 2?
Yeah.
Oh, wait. No, do I times it by 40? Sorry.
Oh, by 40. Yeah.
And then do I add that answer to 1.4?
Yeah. So what's the answer?
7.4.
Yeah, you're fine for these questions. Totally fine for these. You'll be fine. Let's say you'll be fine for these. Okay. Compound measures. We'll do 1.
So do I need to do 20 28 divided by 35? Oh no. Or so 28 minutes, 35 minutes. Oh no, I need to convert. Do I need to convert the minutes to hours?
Yeah.
So uh so it's 35 minutes, like 0.58 hours.
Say it again, sorry. What are you doing?
I did 35 divided by 60.
Okay. Okay. And then?
Do I do 28 divided by 0.58?
Okay. What do you get?
Bless you.
Thanks.
You used to drive like 8 miles faster or something.
Let's see. So full back to Gambia, 40 miles per hour. From Gambia to Horton. What time does she reach Gambia? How would you get what time she arrives at Gambia?
Uh,
And you have the distance and the speed.
do I do 28? Do I do 35 divided by 28 times 10. Or,
No. So time is distance over speed. So let's see. So the distance is 10 miles. The speed is 40 miles per hour. 10 over 40. So that's a quarter of an hour.
okay.
So that's 15 minutes.
Yeah.
So she's at 10. So 10, 15. Okay. So how much time does she have to get to here?
20 minutes.
Okay. So 20 minutes is a third of an hour.
Yeah.
So we want speed. And so it'll be 18 over a third, I believe. So 54 miles per hour, I believe. Let's see. Yes, you've got 1/3 of an hour to go 18 miles, and so you have to go 3 times as fast as that, yeah, to get there. Yeah. So you have to break this up into 2 different parts. You can't do it all in one go. Any questions there?
No.
So we just need to, let's see if I have another one that's similar to that. This might be hour speed. Yeah, okay, how about this one? Perfect.
So, do I need to do 48 divided by 6?
So average speed
Yeah.
is, how do you find speed?
Distance over time.
Yeah, and so the average would be total distance over total time. Let's see. So total distance.
78 miles.
And how can we get total time? Hang on. For the last 48 miles. So we want the average speed for the last 48 miles.
Yeah.
So we'll just consider that 48. And the time. In 6 hours. Okay, how do we get the time it took for the last 48 miles?
So you do 30 divided by 15, which is 2, and then you do 6 minus 2.
Yes. And so that's 4.
Yeah.
And so what do you get?
12.
That's it. So 12 miles per hour. That's it. So you have to figure out one part of it to get the other part. Any questions about that?
No.
Okay, so you can't do it all in one go. Let's see this one. Density minus this. Calculate the mass. Okay. How about this one?
So do I need to do 12 times 5 times 15 and then times that answer by 6.6?
That would be if it was a cuboid. It's a triangular prism.
Do I need to times everything together and divide it by 2?
Yeah.
Okay.
12 times 5 times 15 times a half. And then what's the connection between mass, density, and volume?
Mass is equals density times volume.
Okay, and then just times 6.6. Right, good, not bad. Okay, this one, pressure equals force over area. Okay, how about this?
So do you first of all do 70 divided by 20,
Okay,
and then that's 4.5 there.
yeah.
And then when it says the force is increased by 10 newtons, do you do 80 over 430?
So that's whatever.
Yeah,
Two.
it's just
Sorry.
2.6 on our calculator.
Okay.
And then when there's the pressure decreases by less than 20%, do you do 3.5 times 0.8?
Okay. What do you get?
2.8.
And so,
So she's right.
correct. Okay, yeah, good for that. Let me see this one. Let's see who's driving home for miles. Okay, I might come back to that because maybe. No, don't need it. Okay, we'll do this one.
I do 13 divided by 1.6.
Okay.
It says here it's 8.125. And then do I do 1.4 times 10 to the 8 divided by 8.125?
5. Okay, what is it?
I don't. I'm using my phone. I'm using a scientific calculator.
Ah, okay. Let's take a quick look at this. So that's distance, that's speed. That's miles. Yeah, fine. Okay. You need to practice these ones. Try it.
So do I need to do 25 divided by 50 and 25 divided by 60 and take the answers away from each other?
Yeah, that one was alright. Let's see this one. Yes. Okay, how about this?
So do I do 45 divided by 30 and 20 divided by 40 and then add them up and divide it by 2?
Um, 45 distance, speed. So that's going to be time. So, okay, when you add those two, 45 divided by 30 plus 20 divided by 40. 2. So that gives you total time. So that's miles. Speed is miles per hour. So that's 2 hours. You want average speed. What would you do?
I do 65 divided by 2.
Yes, that's it. And 32.5 miles per hour. That's a pretty perfect example. Any questions there?
No.
Okay. Let's see. I think you're going to be fine for these now. Density, volume, quite good for it. Density, quite good. We did this one. What is this? Ah, yes. All right. It's revision. Let's do it.
Do I do 100 times 8.8? Oh no, sorry. 11.8 over 148.
So what does the significance of this say in like correct the 3 significant figures?
Are they saying that that's not exact or something?
Yeah. And so what could it potentially have been, that 148?
Could have been 147.5
Yeah.
or 148.4 or 5. It was one of the two.
Yeah. 148.5 kilometers. Okay, and then how about the other one?
So it'll be 11.8 divided by 11.75.
Okay, and so what would you do with those now?
So do I do do I do it with the lower bound and then do it with the upper bound, or
You could try both, yeah.
so do I do 100 times 147.5? Oh no, times 11.75
Yeah.
over 147.5.
Um. Put into your calculator. Let's say 100. We're putting. So let's see what 11. I'll use simpler numbers. Okay, so you've got 2 and 5. This is 1.5. This is 2.5. This is 5.5 and 4.5. Let's call this second one. No, that's x. That's y. What is y over x? What's the biggest number you can make? What's the smallest number you can make?
So is it 5.5 over 1.5?
Yeah. And the lowest number you can make?
4.5 over 2.5.
And so that's what you have to do to get the upper and lower bounds when you're dividing. You have to do upper bound divided by lower bound and lower bound divided by upper bound. Not the same for both.
Okay.
And so if you're doing 100 times 11.75, what are you dividing by?
Am I dividing by 100 148.5?
Yeah. And that will give you the smallest number. And then what would you do to get the biggest number?
100 times 11.85 divided by 147.5.
Say it over, what was it?
Over 147.5.
Yes, 147.5. Okay, let's work these out. 100 times 1.75 over 148.5. So that's 7.9 something. So that was the smallest one, 7.9. And so what's the answer to our question here?
So also, could you say Nathan could be wrong because you could use 8.03?
Correct. So any questions about that?
No.
So this one here, it's correct to 3 significant figures, so you have to unround it. So you have to do lower bound, upper bound.
Yeah.
So just something to watch for. And they're almost always wrong with these ones. It's almost never like 7.8 and 7.9. So yeah, he's definitely correct. It's almost always one is 7.9 and the other is 8.1 or something like that.
Okay.
So this one, you're quite good for those. alright. This was the last one. Race. Average speed. They're probably okay for average speed. So what was this one? This was geometry.
The question would be like, when going to the shopping centre, what method of transport do you use most frequently?
Okay. And anything else you do?
And then you need to put out the answers and stuff.
What answers could you do? Anything else? What you'd?
So at the end, like on average, or something.
Do you, let's say, mostly or something like that? I was thinking that. Anything else?
Wait, do we need to put answers?
Yeah, so you need to put some response boxes.
So like train, car, cycle, and then other.
Yeah, I'm happy with that. Fine.
So, okay, so to work out BC, GD, root 3 over 3 plus x equals to root 2 over 2.
Why do you need BC?
For the area, or oh no. Do I just need to work out the area of the triangle at the bottom, the white one, and then I just take that out? Oh no. I need BC to be able to work out like the area of the whole triangle.
You're told that BD is root 2 over 2, so it's an isosceles triangle.
So, do I need to work out the area of the whole triangle, and then of the white triangle, and then that's it.
Yeah, and so minus y equals great. So how would you get the total triangle?
Is it root 2 over 2 times root 2 over 2 divided by 2?
Yeah, and I'll just keep it as times a half. And then?
And then I do, then I do root 2 over 2 times root 3 over 3. And then I take the answers from each other.
Something's missing from the second one. It's a triangle.
Oh, the times a half again.
Correct. That's it. Brilliant. Any questions there?
No.
Okay.
So the area of a trapezium is half a plus b times 8.
Mm-hmm.
I need to do half, right, and then brackets is root 5 plus root 5 plus 6,
Yeah.
and then times that by root 5 minus 2.
And I just want to see if I'm doing right by you. Hang on. Root 5 plus root 5 plus 6. I'm just putting in the times. You don't need to put in times, but just so you can see that two brackets next to each other means times. And yeah, minus 1 plus root 5. So the calculator's doing all the work for you, so we don't need to put it on. I would say for geometry and shape, for the measures, for the average speed, just work out like the distance for each part, the miles per hour for each part, or the time for each part, and then use that to work out what you need.
Okay.
So in this case, they wanted the average speed, and so yeah, you would just work out the time for the first part, subtract that from the total time, and then that gives you the time for the second part, and you use that to get the speed, and so on.
Okay.
Yeah. How was that for you, Andrey?
Yeah, that's good, thank you.
This is good. We're finished geometry and shape, so we'll be on to data next. Any questions for me in general?
I think so.
Okay, well done, Andrey. You did great. I look forward to chatting again next week. And do you have some stuff that you can like practice or whatever?
Like which you have past papers and stuff.
Yeah.
Yeah, we get them from school like every week, so.
Okay, that's great.
Yeah.
All right, well done, Andrey, and yeah, have a good week.
Cheers, bye.
All right, bye. Questions.